Today we are going to be discussing fractions. Before we begin, it's important to understand the parts of a whole definition of fraction. According to the parts of a whole definition of fraction, A over B of a whole indicates that a whole has been partitioned into B equal-sized parts, and we are considering A number of those parts, which is indicated by the letter A in the fraction A over B. We're going to be looking at this word problem. Mary has read half of her book. Later, she reads an eighth of the book. How much more of the book did Mary read the first time than the second? So according to the parts of a whole definition, our whole is the entire book. The two parts that we are considering are partitioning the book into two pieces and considering one piece, and partitioning the whole book into 8 pieces and considering one piece, and then we'll subtract the two. We can think about subtraction and addition of fractions similar to whole numbers, but first we must find a common unit factor, or a common denominator. To do that, we begin with first identifying what our whole is. Using fraction tiles, our whole will be represented by the length of this blue fraction bar, which represents one whole book. Initially, she read half of her book. You can see that this brown tile represents half because this is half the length of 1, which we've identified as our whole. Additionally, she reads an eighth of her book. We can tell that this red fraction tile represents 1/8 because you need 8 of them to equal the length of one fraction bar, the same as you would need 2 halves to be the same length as our whole. Again, we are only considering 1/2 and 1/8. It's important to find a common unit factor. For halves and eighths and many fractions, it's best to start with the denominators you're already given. So first you want to see if you can make 1/2. Make 1/8 be halves. As you can tell, 1/2 is much larger than 1/8. So it's likely that 2 is not the common unit factor. Next, we can see if we can make 1/2 into 8ths, considering the length. As you can see, when I take 4/8, it has the same length as 1/2. Therefore, 4/8 is equivalent to 1/2. Now that I have a common unit factor, I can subtract 1/8 from 4/8 by considering these as my parts of my whole book. So I know that the first time she read 1/2 of her book, which is equivalent to 4/8, and the second time she read 1/8 of her book. And I want to know how much more she read the first time than the second. So I need to take away or subtract 1/8 from 4/8. As you can see, I now have 3/8 of my whole. Therefore, Mary has read 3/8 more of her book the first time than she did the second time. As you can see, this is 3/8 of our whole because we identified this length as our whole book. And if we take our 8ths back and we put them back on, it is equivalent in length. 1, 2, 3, 4, 5, 6, 7, 8. So by partitioning our whole into 8ths, we were able to more easily complete our subtraction problem by finding a common unit factor, the same as you would do an addition or subtraction of whole numbers, as long as they have a common unit factor. We can also represent this problem in an area model. If we identify this large circle, this blue large circle, as our whole, one book, we can now partition that whole into the required fractions from our problem. So from this whole, we now want to partition it into two equal pieces. As you can see, these two brown circles are equivalent in size and area to the blue fraction circle. Additionally, we also are working with eighths. So we need to partition our circle into 8 equal pieces. As you can see, this fraction is equivalent to our whole because they have the same area. Our whole is indicated by the area of this blue circle. And now I have partitioned it into halves and eighths. From my problem, I know I am only considering 1/2 and 1/8. Again, just as with whole numbers and in the linear model, we still need to find the common unit factor to complete the problem. As you can see, we cannot make eighths into halves because the size of the area is much larger. We can, however, try to see if 8 can be our common unit factor, eighths can be our common unit factor or unit fraction, by seeing if we can partition our half into eighths equally. As you can see, by taking 4/8 of my red circle, I have the same area as my half, which is half of the area of my whole. So 4/8 is equivalent to 1/2. Being that I now can partition a half into eighths and I have a common unit fraction, I can complete my subtraction problem. So the first time I know Mary read 1/2 or 4/8 of her book. Later she read 1/8 of the book. So I need to take or subtract 1/8 from 3/8, or from 4/8, giving me 3/8. I can tell that this is 3/8 of my whole because I've identified the blue circle's area as my whole, and therefore can see that this is 3/8 of that whole, because I know if I put all 8/8 back on, I have an equivalent area to my blue circle. Therefore, they are the same area. So I know that 1/2 minus 1/8 leaves me 3/8, and eighths is my common unit factor.